Hello and welcome to this month's CRC Café. My name is Allison Justice, and this month I'm going to talk to you about pH up. What is it? What does it mean? Can you make your own? What are the most popular used brands, etc.? So potentially it's been a while since you've took a plant phys course or really did a deep dive into understanding fertilizer chemistry. But I think it's important to do this to refresh yourself time to time, where you can really wrap your head around your nutrient program and even more so help you understand maybe some of the problems you're seeing. So if you're seeing scaling or weird gel buildup within your irrigation pipes, having a concept of why that might be happening because of some of these inputs that you're putting through your system. You might be doing it to yourself just because you don't know what might be in some of these branded products that are out there. So hopefully this will give you a nice overview of, at least within bases and on the alkalinity side, what's happening and what you might could choose or do to cause a different outcome. So just as a refresher, pH measures the acidity or alkalinity within a nutrient solution. It's from a scale 0 to 14, with under 7 being your highly acidic area of pH, with really what's counting here is being the higher concentration of hydrogen ions. Now, this would be your pH down. This would be your acids. This would be your phosphoric acid, sulfuric acid that you're adding to make this pH be more acidic. Now, what we're talking about today is the alkalinity side, the base side, basic. Now, this would be over 7 in pH in the pH scale. It's a higher concentration of hydroxide ions, and it's what the cannabis industry refers to as pH up. Horticulture industry might call this your bases of your buffering solution, but in cannabis, pH up. And then, of course, neutral being 7, where your hydroxide and your hydrogen ions are equivalent. So keep in mind the pH scale is logarithmic. This means that each time a whole number changes, it's actually a tenfold difference in hydrogen ion concentration. So for example, if you have a solution with a pH of 4, that is 10 times more acidic than a pH of 5 and 100 times more acidic than a pH of 6. So when you have these wild swings that don't necessarily make sense when you're going up or down in your pH, just keep in mind it's because of this scale. Now for crops, general horticulture is expected optimal range being between 5.5 and 6.5. Now you might ask why? Why does this even matter? And so this next chart, nutrient availability, this is what it's all about. This is why we care about pH and the chemistry of our plants, because if your pH is out of whack, again, what the cannabis industry calls locking out, then you will actually block nutrients from being absorbed, either blocking from absorbed, or these elements will form with other elements where they completely fall out of solution and they are no longer able to be transported because they're at the bottom of your tank and clogging your filters. So looking at this chart, this is extremely important to know. You should print this out and put it on the wall where your growers understand the importance of this. But I've highlighted here the 5.5 to 6.5, and you can see from strong acid on the left to strongly alkaline on the right, there are differences in the availability of these nutrients to plants. And so if you were to go lower than 5.5, that's where iron is extremely available, and that's blocking the uptake of other elements. Whereas if you're on the other side of that range, you're really having potential tapering down of the calcium, magnesium, and phosphorus. So staying within this range is where you want to be as a grower. Now, there are certainly more specific pH targets that you may find you need to hit for certain varieties or certain starting water that you're dealing with. But this is a nice general recommendation that all of horticulture really should stay in. So next, what type of pH ups can we actually use? Now, right now in cannabis, this question is answered by giving you a brand name, right? Well, what type of pH up do you use? Well, I use General Hydroponics, I use Athena, et cetera, et cetera. That isn't what we should be recognizing use in our precise systems. It should be what type of compound do I want to use based off of my program, based off of my water, and then go to brands and find the consistentness that you want to work with your products. So I'm going to start here. The four most common, and there are others for sure, but the four most common used in hydroponics is potassium hydroxide, potassium silicate, potassium carbonate, and then potassium bicarbonate. So the first thing that sticks out here for me is, well, these are all potassium based. Why? It just so happens that potassium based bases buffers are used is for a few reasons. One, of course, it is an essential macronutrient, so the plant needs it, so this gives a good reason to use it. But keep in mind, we already over apply potassium, so if you're adding a lot of this, you are adding that on top of your fertilizer base that you're starting with. It blends well with other nutrient components within your hydroponic system. So, unlike just acidifying water for a certain reason, you are acidifying a component of, a solution of fertilizers that are really high ppm, and they all need to play nice together. And so this one does play nice and such setups. It dissolves really well in water, which of course we need. Um, it provides less precipitation versus a calcium-based product, and precipitation means when an a compound binds with another, and then it precipitates out, meaning it falls to the bottom and actually becomes granules that will not dissolve in water, and that is something we do not want in horticulture really growing. Um, and then, of course, there's lots of other really good pH up products that you could use for other systems. Let's say changing the pH of growing substrate for mushrooms, or there's all sorts of reasons you would want to change a pH of a solution with it not being used for plants. And in those cases, you might want to use something that doesn't have potassium as one of the main elements. Maybe it's a sodium or a chloride, because those elements do not mess with the application you're using for. But in cannabis, in horticulture, some of those good pH adjustment tools that do contain sodium or chloride is avoided because that's built up, right? We're already struggling with those sources coming from our water supply, so adding more might not be the best choice. I've already mentioned buffering, but I want to go ahead and make sure we have a definition for it for the next few slides. So buffering, what is it? It's the ability of a solution to resist changes in pH when small amounts are added, that being acids or bases. Buffers are typically weak acids or bases that react with acids and bases. So that all may sound really confusing, but in short, your buffering capacity is extremely important. Now think of this example. You have made up some fresh RO, right? You add fertilizer that might not have a buffering agent. you add a little bit of acid or a little bit of base, and it swings super fast back and forth. And so you're adding a drop, and it goes up 10 points, and the frustration is there. Well, for your plants as well, if there's not enough buffering effect in your fertilizer solution, that's what's happening for the plants as well. Not only what you're actually feeding it, but depending on the type of media that your plant is growing in, let's say rockwool, for example, there's no buffering capacity in that media as you would in soil, let's say outside, that already has a lot of this control. It has no control. There's no room for swing. So when the roots start pumping out certain ions that it does in certain cases, you're having those crazy swings. So making sure that your solution is not just at a certain pH that's correct, but that buffering is there as well to control these swings that you're purposefully doing, potentially making your solution more acidic. Um, it's slowing that change, and that's what you want to have um, a very precise and homogeneous solution. So buffering is important, and the next few slides will go through that. So I made this table looking at the 4 different types of pH substances. Now across the top here, we've got the different types of potassium. First, we've got the chemical formulation. Second, we've got pH adjustment. Now, basically being, is it a gentle adjusting, meaning slower, or fast, wrong, moderate? Now, potassium hydroxide is by far the strongest, which may seem like a good thing, but if you're on a very small scale, this might be too fast, and you might have to dilute your starting solution in order to have the control that you want. But that is something to keep in mind, because you might think that's a good thing, but it does come with some other downfalls. The type of substance it is, so is it a base, is it a buffer, or is it a little bit of both? Because it can have both. Potassium silicate is a great choice to provide both of those aspects that you're looking for. But again, there are pitfalls as well with potassium silicate. So let's keep going. Let's keep in mind, this isn't just some magical substance that only changes pH. This is adding elements that are nutrients for the plant as well. And so that might be a good thing. It might be something that when you're if you're mixing your own salts, for example, it should be a consideration when calculating how much potassium you want to put in your formulation. So keep in mind, it's not just pH adjustments. You are adding nutrients to the solution as well. Um, you know, silicon has a lot of great features. I've seen the benefits in other crops as well as cannabis, but it can be tricky with dealing with combination with other elements with pH. There can be a lot of precipitation or even some weird gel growth that happens. So understanding when using these pH substances, how's it going to operate with silica if you're adding silica? Potassium hydroxide has a high reaction. Potassium silicate, it's a moderate reaction, and this would be in addition to the silicate that's being added on top of your potassium silicate that's used as a pH adjustment. Um, Whereas potassium carbonate and bicarbonate are both very low as far as precipitation risk. So depending on if you are adding supplemental silicone, this is something to keep in mind. Now, next is the safety, human safety aspect, as well as mechanical and equipment safety. Potassium hydroxide works fast, works quick, but the downside here is that it's extremely corrosive and caustic. Now, the next slide we're going to go over, what does that mean exactly? Um, because that was my question. Let's give this a definition where we understand what we're working with. How negative of an aspect is it? As long as I'm not pouring, the pure solution onto my aluminum tables, am I okay? So um, KOH, very corrosive, and then of course as you go down, potassium silicate being moderate, with the next two being extremely safe. Now this is something to keep in mind when we're looking at the different fertilizer brand or the different brands of pH up, and um, why some compounds are chose over the others, with this caustic, this corrosiveness being one aspect. Because if your product is corrosive caustic, you're actually going to have to pay a difference for shipping cost. And so just because what's on the market is not potassium hydroxide, that does not necessarily mean that that might not be your best choice. What's being avoided here is that extra cost of shipping. Of course, and if you're with a team that you don't necessarily trust to follow directions and to be safe and wear respirators, then maybe just going with a safer solution is the best choice, and that's fair. Cost, now this is just general cost of raw elements. Um, so keep that in mind here, just a basic guideline. Potassium hydroxide is moderate, potassium silicate is the highest, potassium carbonate is the lowest, and then potassium bicarbonate being moderate as well. They all have great solubility, which is why we've chose to use them anyways. And then one other thing to really consider is the use of risk with hard water. Now, a lot of places have hard water, and that can be a problem. It comes with a lot of people going to choose to use RO, which is fine, but it can be extremely costly, and then you're adding your pH up right back to it. So, but we'll go on to talk about hard water and what that looks like when using these products. But in general, what to know is potassium hydroxide. If you are using just straight hard water, you're going to have a good bit of precipitation from using potassium hydroxide. And then as you see in the rest of the table, it goes from moderate to low and very low. So this is just your 100-mile up overview, and we'll dig into this a little deeper. So what does that really mean to be corrosive? Well, it's a chemical property where a substance can cause damage or destruction to material, surfaces, living tissues by chemically reacting with them. So corrosive substances are usually acids or bases, and they can vary on the effect due to what it's touching, due to the duration of exposure. And so it's a big range. Think about lemon juice. So lemon juice on your skin, no problem. Maybe it causes some people a little bit of sensitivity in their mouth, but ultimately no problem. Whereas if you have hydrochloric acid, well, that might actually break down complete floors and would destroy your tissues if it were on you in a certain concentration. So there are ranges of corrosiveness that we really need to look out for. So the two takeaways here is read your SDS. Whether you are using a branded product or raw ingredients, understanding, and I should have human safety on top here, but understanding what type of metal are you storing these products in, of course, is an important one. What type of area are you preparing these products in? And then most importantly, of course, reading that SDS, making sure that your team is wearing the proper PPE. Read the SDS. Is this something that is very dangerous, more like the potassium hydroxide, or something a little less dangerous? I mean, obviously they should be wearing the PPE that the SDS says, but if you are mixing your own pH up, it's really important to understand the range of corrosiveness you're working with, because that's human safety. So how do you store a corrosive substance? Now, keep in mind that this goes for branded products or if you're bringing in raw ingredients. These are good protocols to live by, to keep you and your team and your plant safe. So general storage and conditions, you want it in a cool environment, just like you would keep any input product that you're putting into your grow. You don't want it to change from the the form it was in when it was made, right? Sun, time, all of these factors can cause to degrade your product and change it from what you're actually wanting it to be. Um, Keep these products in ventilated areas, mainly to keep your staff safe. And then one of the biggest things is make sure you're sealing it properly. Especially the powdered materials such as KOH or even the Athena brand product. Um, these products are super absorbent. So if you don't close it right, it's going to become one big block and it's not going to be or do what you're expecting. Now, we want it to be in tightly sealed containers, not only because it's going to absorb that water from the air, um, but it's going to form different substances. Specifically here, we're talking about KOH. So when KOH reacts with the air, because let's say your lid's not on all the way properly, you're going to cause potassium carbonate. So you are changing the substance um, that you purchased. So keep it closed. It'll stay as it is, what it is, and not full of water. Now, again, if you're making your own pH up, potentially by using KOH, this one specifically, this is the very corrosive product. This is the one that you need to have in a special storage area, away from acids, away from ammonium salts, and away from metals, specifically aluminum and zinc, because it can violently react. Now, when you're buying in bulk, maybe you get a 55 pound bag, and then you might want to put it into a different container just to make your life easier, where you're not having to deal with that 55-gallon bag. Fair enough. But what you got to keep in mind is with corrosive substances like this, there's a whole science to the type of plastic, the type of container that it's in, because of how it can chemically react. So I wanted to make sure if you are doing this, have it in the right type of plastic. And for goodness sake, do not put it in mason jars with a metal lid, because it's going to explode and cause a lot of problems. But keep it safe, keep it simple. Right here, you can see different types of right here, you can see different types of plastics that is okay for using specifically with potassium hydroxide. So HDPE, PP, PT, FE, all okay. What you want to stay away from, any metal, and then PVC. Um, these products will break those plastics down, or the metal, and cause you a lot of problems. Now, I know you might be saying, well, my irrigation lines are PVC, and that's okay, because what would be applying to those lines are well diluted. We're talking keeping your bulk materials safe, and not in a way that they will change or become dangerous. So let's pop back to hard water, because this is something that so many of us struggle with. And you can't do much about it because it's from nature. What happens is the water washes over rocks, particularly if you're in a limestone, chalk, or gypsum-rich area. And so what happens is those minerals go into solution and they stay there until they arrive to us, usually magnesium and calcium. And so what this does is absolutely fill the water full of carbonates and bicarbonates and causes a slight alkaline type water. Now, because we are adding pH up in many times, you might think, well, isn't this a good thing? No, not necessarily, because what this can do is leave scale everywhere. If you're in a hard water area, you may see this in your shower. There's weird white scale everywhere. And so this is what can happen in your emitters. The other thing is that these high levels of magnesium and calcium, if you're adding this on top of already what's in your fertilizer, then you might actually be precipitating out other nutrients that are in your solution, um, instead of actually adding more, which is what you might think you're doing. Now, if you have your own fertilizer program where you're mixing your own fertilizers and the only things that are slightly elevated are calcium and magnesium, then maybe that's a great thing, and maybe you just reduce that from your calculations from the fertilizer that you're creating. So there's a lot of chemistry and science that goes into it, but all these are things that are very important to understand, where you can wrap your head around what's delivering, what are we delivering to the plant the most effectively, and two, are we clogging our emitters? Are we saving money by doing this? Are we growing good plants? Now, as we've talked about, by having these buffers, it makes pH harder to swing one way or the other. Now, when you're working with hard water versus RO being complete opposite, no carbonates, bicarbonates to help be a buffer, you'll have a really hard time getting that pH to change. Um, so it's really hard water that a lot of people with ROs are using ROs for, is to get out all of these carbonates, bicarbonates, where they can add a fertilizer regime that works well, and then add the buffering systems and acids and bases on top of that to make a complete program without precipitating out. Now, I think what this has caused in the long run is a extreme overuse of RO systems. I've seen grows that have almost perfect water, and they've went out and spent a couple $100,000 on giant RO systems because they think that's just what you need to do. It's not. This is a tool. This is a understanding the water chemistry is a tool, and it's not one size fits all, because there are other filtration systems and swapping systems than reverse osmosis. Now, there's some locations where you're right on the cusp of needing pretreatment. You're, right on the cusp of needing actual reverse osmosis or water softening, or some other filtration type system. But in those locations, again, knowledge is power. And so understanding if you do actually need better buffering capacity with borderline hard water, what types of pH up can you use, and what would make the most sense, mainly to reduce precipitation. Now, I'm not going to read this out completely, but it does show you some pretty interesting reasonings for reactivity with the different compounds used for pH up. But in short, the smartest move, the best move to make if you do have hard water, is potassium bicarbonate, because it is minimally reactive. You're not going to have as much precipitation happen. And so knowing all of this information on the chemistry, knowing what that, for lack of better words, active ingredient is to get you there, then going back to your brands and saying, okay, well, if I'm not making this from raw ingredients, what is the smartest choice that I can make because of my hard water, because I use silica? And so let's hop on over and talk about those different brands and what the comparisons are, what they are, and how much they cost, and what the differences are. Well, let's dig into some of these commercial products. So I've separated it out between liquids and dry powder. Now, liquids it's quite frustrating to go through, because they're either not telling what's in the product, or they're giving some ridiculous range. Now, I get it from both sides. On one hand, you want to be proprietary, you want to keep stuff tight to the hip. But on the other hand, as a grower, as a scientist, as someone who wants to know what's going on, where I can understand my full system, this is lacking for me. Um, I think there's some gray areas within fertilizers, especially products like this, where there is wiggle room to purposefully be gray in order to protect your IP. Um, but again, I don't personally like it. Um, so all I can really do is look at what the cost per liter is on this concentrated solution, as well as throw you some guesses at what's going on. So in general hydroponics, they're pro pH up. It literally has question marks everywhere. If you look at the SDS, it's like nothing's in it, and that is not possible. They might not legally need to tell you what's in it, but there's obviously an active ingredient that is changing pH. So, I've tried to kind of dig down and understand what that might be, but given that their description claims that it does not contain potassium, that makes you think, all right, well, maybe it's sodium hydroxide, one of the similar substances, just with sodium versus potassium. But I think that would be on the caustic list, and then they would have to disclose. So I don't actually know. It could be some sort of amino acid. I don't know. That's concerning to me. Advanced nutrients and drip hydro are both potassium hydroxide, which are fine substances. And then Athena's Balance Blend, which, correct me if I'm wrong, but I believe that's more of their home grower formulation, is potassium silicate. So that's a pretty interesting product, being that it's the only one that I've seen, through the companies that I've went through that has the silicate formulation. Um, but the percentage there is proprietary, so I'm not sure without testing what that would be. So, what this brings us to really is understanding you're not going to be able to adjust due to your ppm of the substance you're using. This is really just going to be a crapshoot of, well, in my system, one shot glass changes it, and two is too much. Um, and what we can also do here is look at the cost per liter. Now, that's not quite fair because general hydroponics, their 1 milliliter of solution might be twice as potent, for lack of better words, than the advanced nutrients. And so, being that concentration, the cost per liter isn't necessarily fair. But because we don't know what's in it, this is what we're going to look at. They're all pretty similar in terms of cost per liter. Advanced nutrients is a little bit higher, and I should have said this sooner, make it clear that the prices I'm pulling are straight off retail. Quick Google. This is not bulk discount pricing. This is just what I would get right there by Googling. So of course, as a big grower, you may be getting much better pricing, but this is my comparison. Now let's dig into the common pH up products, this being dry powder. Now, this is by no means all of the brands that are out there, all the ones that matter. These are just two quick ones that I picked. Athena being a commonly used, their Balance Pro formula, and then generic just being raw ingredients, both potassium carbonate, dry powder formulation. Now keep in mind, this is not bulk discount pricing. This is just what a quick Google shows without the thought of shipping. So make sure to compare this with the pricing you get. Here we're looking at different size bags, different styles, but what's important is to look at your gram per gallon. Now, that might look like a huge difference, which it is 75%. I think there's a little more information you'll need before saying, well, crap, throw one away versus the other. So grams per gallon of used material, this is what we'll get into in the next couple of slides. So this is a real life scenario. One of our members gave me this information because he is using this product in his facility where they do have to use RO. So we used RO water, and they're using the Athena balance. I had to pick a percentage to use to adjust for purity, and so I'm going with 99%. So in his example, what he does is he'll take 1 pound of the potassium carbonate and dissolve it in 25 gallons of water. Now this makes his stock solution for injectors, and that puts us at 4.7 grams per liter as far as our potassium carbonate concentration goes. From there, his injector injects at a 12 milliliters of solution to a gallon of water. So that takes us down to a final concentration of 0.015 grams per liter used in conjunction with his fertilizer program with RO water. So that gives us an actual number that we can use and compare and really understand what we're putting on our plants. Now let's make this make sense in your grow. So in this example, we're looking at 10,000 plants in flower. We're watering at a half gallon a day, putting us at about 5,000 gallons per day used. Now we can take the information on the slide before at the cost per gram with each substance and do the math here for the 5,000 gallons a day. Transfer this to a year, and we're looking at a cost savings per year of about $381, which that number doesn't, that's not a huge savings, but then when you look at it by percentage point, that is a pretty good savings. The other thing to keep in mind here, though, before you go out and start making all your own fertilizer inputs is that, when you're working with raw ingredients, you need consistency. So you need consistency of where it's coming from, its quality. Are they able to supply it to you in a consistent manner? If it's part of a fertilizer program, the cost per gram may significantly go down. So there's a lot of things to look at before making this switch. But I was pleasantly surprised that the savings wasn't a lot more than this. But let's look at one more thing that I feel is extremely important. And that goes back to the earlier slides where I said this isn't just pH adjustment, right? This is actually adding potassium to your fertilizer. Let's calculate how much. Because phosphorus and potassium are already wildly overused in cannabis cultivation, I thought it would be interesting to understand how much more potassium am I adding to my fertilizer by using potassium carbonate. So the actual pH up substance, potassium carbonate, is potassium. So how much, in addition to what's already in our fertilizer solution, are we adding? Now the number I'm looking for is parts per million because that's what makes the most sense when I'm looking at how much nitrogen is in my fertilizer solution, how much potassium, phosphorus. So let's do the math to figure this out and do a little stoichiometry. So what we want to look at is, first step is finding the molecular mass in grams per mole for K2CO3. All you do is take the molecular weight, which you can find on your periodic table. So for example, potassium is 39.1, and we'll times that by 2 because there are two potassium elements here. We will add that to carbon. There's only one carbon, so 12.01, and then we'll add that to oxygen's molecular weight is 16, and we'll times that by 3 because there are 3 oxygens. So that gives us a total weight of about 138 grams per mole. But we only really care about potassium. So we will take the total molecular weight of potassium and divide it by the weight of the full molecule. And that puts us at about 56.5% by weight of potassium. More math, and what we find is that we're looking at adding about 8.5 parts per million of potassium into the fertilizer solution just by adding a pH up of potassium carbonate, which is a common pH up substance. So I thought that was pretty interesting, not quite as much as I thought it was going to add, which is a great thing because you really want that control of formulation there on the fertilizer side, not necessarily there where you're adjusting pH. So for me, my understanding after looking at all of these options is that really potassium carbonate is the best option. Whether you're buying that from a brand or whether you're making it yourself, looking between all the pros and cons, this is today's best choice. The other thing I want to do is make sure to keep exploring this. Look at KOH, potassium hydroxide, which is a caustic substance, right? It's a little more risky, but it's also a lot more aggressive. And so if done properly, can we use KOH to really reduce that input cost, maybe not add as much potassium and have a greater effect? So the exploration is not over, but I hope this gives you some guidelines around what the heck pH up is and what makes the most sense to use in your facility.